Okay then, thank you for your enthusiasm. Molar mass is what? No, come on. Grams per mole. Thank you. We want grams per mole. How are we going to get grams? We are going to weigh it. How are we going to get moles? No, freezing point depression. So that is what we are going to do. We're going to weigh our sample to get grams. We are going to take and use freezing point depression to get moles. So let's go back to what it is we know. So we're going to go to a phase diagram. Because we understand phase diagrams, yes?
Yes.
Yes. On the y-axis we have pressure. On the x we have temperature. And our solvent is what in today's lab? Naphthalene. That, by the way, is mothballs in your grandmother's house. I know, right? What does this look like? We know that the curve between the liquid and the gas is a nice exponential. We know that naphthalene is going to be a normal substance, meaning its slope is going to be positive, and we're going to have our, again, solid gas interface here. Freezing point. Freezing is this interface right along here, yes? And what's going to happen when we add a non-volatile solute is our freezing point will drop. Yes?
Yes.
Such that if we are at 1 atmosphere here, that our freezing point change is this value right here, delta T sub F. We know our equation. Our equation is delta T sub F is equal to Im K sub F. Delta T is going to be the change in temperature, such that we're going to take the old freezing point, the one for the solvent. We are going to subtract the freezing point for the solution, and that is going to give us our delta T sub F, yes?
Yes.
Okay, we know that this is going to be a positive value. All right, now, Im K sub F, since naphthalene is a nice organic solvent, I is equal to? 1. And K sub F is given. What is K sub F for naphthalene? 6.8. 6 degrees C per molal? Yes? Good. And what is molal? What is molality? Aha, moles of solute. Kilograms of solvent. Thank you. Kilograms of solvent. Clearly we are not going to use 1 kilogram of naphthalene because that's a lot, right? Tell me 1 kilogram's a lot.
Yes.
Thank you, we use a little bit. All right, so with all of this, this still doesn't answer the question of how we are going to measure the freezing points. So let's think about this, because what we're going to do is we are going to generate a graph. We're going to look at temperature versus time. Because here's what we know what happens. We know that if we take naphthalene and we melt it, we are going to get liquid naphthalene. And if we take liquid naphthalene and let it cool, its temperature is going to go down, and our temperature is going to drop. Our temperature will drop as we go from a liquid until we get to our liquid solid interface. What should happen to the temperature at that point right there? What happens to the temperature as something boils or as something freezes? It plateaus, correct? And that's what it should do. It should plateau. It will plateau if we had it in like a thermos in an isolated environment, but we don't. We're going to have it out in the room, and the temperature is going to look something like that. And you go, okay, so what's what? The intersection of the two best fit lines. So you're going to have to, by hand, draw 2 lines in. One through the cooling of the liquid, one through the freezing of the liquid, of the solid, excuse me, and that point right there is the freezing point. You good? Now, to make sure we do this correctly, we have to stir at all times. Stirring at all times. And we're going to do this in 2 steps. 1, we have to find the freezing point of the solvent, and 2, we have to find the freezing point of the solution. So step 1, you're going to take, and you're going to get a hot plate, You're going to turn it on nice and warm. You're going to put a beaker full of water. Water is going to be our heating source here. And we're going to put a beaker full of water, and we're going to put this on nice and hot. You're going to do this under the hood because naphthalene stinks. We good? Okay. Now, that's part one. Once you get part one, we need a couple of things. We need to weigh our naphthalene. I know the instructions say 9.5 to 10.5 grams. Please ignore that. We are cheap. Weigh about 5 grams. Make sure when you weigh about 5 grams that you do this to 3 digits past the decimal. So when I weighed my sample, I weighed out 4.8572 grams. Make sure it's about 5, but to a few digits past the decimal. We good? Do the same thing with your unknown. Weigh about 0.5 grams of your unknown. I am using unknown number 3. Pick out unknown 1, 2, or 3, weigh out about 0.5 grams. Are we good? Yeah. Now, in order to get our freezing point depression, we have to do 2 points. 1, freezing point of the solvent. 2, freezing point of the solution. The setup is straightforward. You have your beaker and your hot plate. The only other couple of things you need is a ring stand, a clip, and what we call a gas bottle. So, if you come over here, I'll show you what we're going to do. You're going to take, pause, you're going to take a nice fat test tube. You're going to take your carefully weighed naphthalene sample and you're going to put it into the test tube. And we're going to start out with our naphthalene as we do our freezing point depression. Try not to pour it all in. Obviously, you're going to get a little bit left over in your container. We can't fix that. And you're going to just leave it there. Make sure, of course, that at this point, you have on your goggles. Fantastic. I have my goggles on. Now, you will go to your hot water. As soon as you open these things, pretty much they're going to start beeping. And you're going to take your nice sample of solid naphthalene, and you are going to set it into your boiling water. Clamp down very carefully. Do not clamp down hard. And whatever you do, do not take and hit anything onto the bottom of the test tube. It will shatter. And it makes a mess because, among other things, naphthalene is non-polar and it doesn't dissolve in water. It does all sorts of weird things. So you'll heat up your naphthalene sample. Once your naphthalene sample is nice and hot, and by hot, it needs to get to about 90 to 95 degrees. It needs to get well above the melting point. Otherwise, you will not get enough points going down on your curve. So, you get a nice hot sample of naphthalene. You'll take your naphthalene out, and you will set it into one of these guys. This is a gas bottle. You will get your thermometer and a stirrer. And it really looks just as silly as that. You'll read the temperature. You will get your cell phone, set your stopwatch, and you will take the temperature every 30 seconds as you stir. And you have to stir, otherwise it will cool unevenly and you'll get crystals and it won't work at all. We good? And you'll keep stirring. Now, there's a lot of space to write data on your data sheet. You do not need to fill all of that out. You need enough points such that you can get the cooling of the liquid and the freezing of the solid, which means you only need 5 or 6 points here at the end. So even though there's space for 30, you don't need it. We good? At that point, you have found the freezing point of the naphthalene. You'll take your sample and you will put it back in. Once you take and you put your sample back in again, you're going to get melted naphthalene, correct? But what do we need for part 2? The unknown. So you're going to take your unknown and you're going to add it. You can add it out while it's in the gas bottle. Any way you do it carefully so that you add your nice unknown to this. Do not stir it until everything is nice and melted. We cool? Once it's nice and melted, you can stir that as well. Again, get the temperature up somewhere between 90 and 95 so that you can do exactly the same thing. Once this has all nice and melted, you're going to take it out, you're going to set it into your gas bottle, and you are going to stir while you record the temperature. At this point, what you have is a container of semi-solidified naphthalene and unknown, which now we have to dispose of. How do we dispose of it? Hazardous waste, thank you, the chemical waste container. To do that, melt it one more time. And once it is nice and melted, the hazardous waste container is over in that far hood. It's going to be labeled hazardous waste for naphthalene. You are going to take your melted sample and you are going to pour into the hazardous waste container, and then you'll rinse with small amounts of acetone to get the remainder out. Are we good? At that point, your experiment is done. Experiment is done? Good. Except your calculations are not done. How do you have to finish to get your molar mass by freezing point depression? You're going to have how many graphs? 2. They're going to both look like this, yes? One of the intersections is the freezing point of the solvent. One is the freezing point of the solution. You're going to get delta T sub F. We go back to the equation, and we know that delta T sub F is equal to IM K sub F. So what are we going to plug in? Delta T. I is 1. Molality is moles over the mass of your solvent in what units?
kg.
In kg. Solvent in kg. And then you're going to multiply it by K sub F. Solve for moles. Take the grams that you weighed out of your solute, your unknown, divide it by your moles here, and you've got it. I will put the identities of the 3 unknowns on the board, but it's also in your lab manual. Do a comparison, see which one you think it is. We cool? Fantastic. Have a good time, wear your goggles.